Hello, this is Pre-Algebra, section 10-8, and we're studying roots of monomials. Okay, and up until now we've talked about multiplying monomials, dividing monomials, powers of monomials, and now we're going to be talking about the roots of monomials. Okay, and that's going to involve things like square roots. Okay, so but before we get to square roots, let's backtrack a little bit. And I want to know, does anyone remember what a perfect square is? Okay. A perfect square is any square of an integer. Okay. So 2 is a perfect, 2 squared equals 4. 4 is a perfect square because it's the integer 2 squared. All right. 9 is a perfect square. 16, 25, 36, 49, and etc. Those are all perfect squares because they're the squares of integers. So now let's say that we have a value 100. What two things multiplied together give you 100 but are themselves perfect squares? Well, you look at the factors of 100, okay? There's, 1 in 100. There's 2 in 50, okay? 4 in 25, 5 in 20. You get the idea, okay? So of those, what ones were perfect squares, okay? Well, I will tell you. 4 and 25. 4 times 25 gives you 100, but 4 is a perfect square, and so is 25. All right? So what are the square roots of 4 and 25? Well, the square root of 4 is 2. The square root of 25 is 5. Great. So what is, if you took 4 times 25 and got 100, what's 2 times 20? What's 2 times 5? 2 times 5 is 10. What's the square root of 100? 10. Okay. That's what we're going to be studying here. That brings us down to this guy right here, the product property of square roots. And it says in words just exactly what we just figured out here. Okay? That it says for any numbers a and b, where a and b are both greater than or equal to 0. In other words, they're not negative. The square root of the product, a times b, is equal to the product of each of the square roots. All right, and so their example here is 9 and 16. Okay, so they break it apart like you can do under a radical sign into the square root of 9 times the square root of 16. The square root of 9 is 3, the square root of 16 is 4. 3 times 4 is 12. Okay? And you'll find out that 9 times 16 is what? What? Yes, 144. So the square root of 144 is 12. In variable terms, algebra terms, if you have the square root of something a times b, then what that really means is that it's the square root of a times the square root of b. Okay? So let's go down here and work example 1. Example 1's on page 559. Okay, and it says to simplify this guy, the square root of 4y squared. Well, okay. What do we do? Well, we break this up. Okay, the square root of 4 times the square root of y squared. Sorry. So what does that look like? The square root of 4 is 2. The square root of y squared is y, right? Not quite. Okay. Not quite. And this is y. In variable terms, if you had a square root of x squared, all right, and you wanted to find out what this was, then that means that that's the square root of x times x, okay? Just like the square root of 4 was 2 times 2, okay? So that means that the answer is x. But you don't know the value of x. You don't know whether it's a positive or a negative. So how do you make it a positive? You go like that. You have to use absolute value signs around the x, okay, to force it to be positive. All right. Okay. And that's from the property of square roots. So we come back over here then, all right? And since 4 was positive, then we're going to assume that the root is positive too. So we're going to leave 2 as a positive, and we don't have to use absolute value signs around the number because we know what it is. It's the variables that we don't know what they are. So the square root of y squared gives you, let me rewrite that over here, okay? We have the square root of 4 times the square root of y squared. So then the square root of 4 becomes the square root of 2 times 2 times the square root of y times y. Okay? So the square root of 2 times 2, well, that's the two things multiplied together. That becomes just the 2. And the y times the y, that becomes just the y. But since we don't know which one of these, or whether they're positive or negative, we have to use absolute value signs to force it to be positive. Okay. We'll get into that in a few minutes about a little more formal as to how or why you use absolute value signs. At this time, why don't you pause the video, okay, and give this one, example 2, a shot on your own and see how well you do, okay? All right, we're back. Hopefully you did pause the video and give this a shot. Simplifying the square root of 36 times q to the 6th, okay? So this turns out to be the square root of 36 times the square root of q to the 6th, all right? Well, the square root of 36, what two things multiplied together give you 36? 6 times 6. And what two things multiplied together give you q to the 6th? Now this is where you need to go back in the previous sections and remember what's going on. When you multiplied polynomials together, monomials together, what did you do with their exponents? You added them, okay? So what two things that are the same added together give you 6? 3's. Okay, so q to the 3rd times q to the 3rd is q to the 3 plus 3, q to the 6th. Okay, so then we come over here and we evaluate this again. So the square root of 6 times 6, well, we just bring the 6 out, and since 36 is positive, we can pull out the positive 6 and call that good. Q to the 6th, however, all right, breaks down into q to the 3rd times q to the 3rd. Q to the 3rd can actually be a negative number, okay? So to force that positive, we have to say q to the 3rd with absolute value signs, okay? And there you go. All right, moving on. So we went from square roots. Now we're going to talk about cube roots. All right, and you're like, what the heck is a cube root? Well, if you want to know the English, the mathematical definition of a cube root, okay, brace yourself. Right out of the book. The cube root of a monomial is a monomial whose cube is that monomial. Got that? Perfect? Clear? Okay, well then we can skip this and move on then, right? Yeah, I don't know about you, but that was, yeah, that was confusing. So how about we work this out in numbers, and I'll show you what a cube root is, because it's not really that hard. Let's say you had a number 8, okay? And you want to find out what the cube root of 8 is. Now, if we had the number 9, okay, and we wanted to find out what the square root of 9 was, that means that we want to find out what 2 factors you multiply together to give you 9. And that would be 3 times 3, right? So the square root of 9 is 3. When you say something is squared, what's it the power to? It's the power of 2, okay? So sitting out here in front of the radical sign is an invisible 2 when you're talking about square roots, okay? That's the only one that it's invisible for. When you talk about cube roots and any higher order root, you have to put the number in that little nook of the radical sign. So when you talk about the cube root of 8, this is how you write it. Okay, a little 3 here with 8. So what's that mean? That means we want to find out what 3 factors, 3, multiplied together give you 8. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. The cube root of 8 is 2. Okay? Right. So if you had something over here, the cube root of a to the 3rd power, that becomes the cube root of a times a times a, right? Because that's the exponent tells you how many times to multiply the base together, right? So the cube root of a to the 3rd is just simply a. And I want to caution you to always write this 3 when you're talking about cube roots. Don't just draw the radical sign and call it a day, because that will be incorrect. Our radical sign, square root sign by itself, simply means a square root, not a cube. So we come down here now, this product property of square roots. And it says, for any numbers a and b, the cube root of the product a times b is equal to the product of each cube root. All right. So they use this value, the cube root of 216. Well, what 2 things multiplied together give you 216? And each of those are perfect cubes, basically. Well, through a lot of trial and error on your part, it would turn out to be 8 and 27. Okay. We've learned from above that the cube root of 8 is 2. The cube root of 27 would be 3 times 3 times 3. So therefore the cube root of 27 is 3. Those 2 things multiplied together, their product is 6. Okay, so the cube root of 216 is 6. And that's what they're saying here. And then likewise in algebra terms, the cube root of a times b is the cube root of a times the cube root of b. Let's do example 3. Okay. Example 3 is going to be on page 560. So we want to know what the cube root of c cubed is. Okay. Well, the cube root of c cubed is equal to the cube root of c times c times c, right? Which is equal to c. All right, well, that wasn't too hard, okay? So if you want, you can pause the video and give this one, example 4, a try on your own and see if you can make it work out. Okay, we're back. If you gave this a try, great. If not, then we'll work it out together here. So the cube root of 64 g to the 6th. Then what this can turn into then is the cube root of 64 times the cube root of g to the 6th. All right, well, the cube root is 64. What three things multiplied together give you 64? Well, how about this? How about 4 times 4 times 4? Think that'll work? I think so. What about the cube root of g to the 6th? Well, remember from our multiplying monomials section that if you have three terms that you multiply together with exponents, you add their exponents. So what three things that are the same added together give you 6? G squared, G squared, G squared. Okay, 2 plus 2 plus 2 gives you 6. Okay? Great. So the cube root of 64 then is 4. Again, positive because 64 was positive. And now we come to this guy, g squared. Okay. Will g squared ever be negative? No. G squared itself will never be negative. Now, what makes up g squared can be negative, but when you multiply them together, they become positive. So you don't need any absolute value signs around this to make g squared positive. G squared will always be positive. All right, so that's the answer to this one. Okay, so example 5. Express the length of one side of the square whose area is this guy right here. 81 y squared z to the 6th square units, and express it in simplified form. All right, so for those visual learners, if you have a square, the question is asking then, what is the length of one side? Well, since it's a square, then all four sides, okay, are the same. So when you take a square and you find the area, that means you multiply side times side, right? So in formula form, area is equal to side squared. Well, we know that this area right now then is equal to 81 y squared z to the 6th, and that's equal to s squared. We want to know what's s. How do we find that out? We take the square root of both sides. 81y squared z to the 6th, s squared, we take the square root. Okay, so working on the right side here, this would be s times s, so that just means s. All right, the side length s, that's just our variable. This is the part we want to worry about. 81 y squared z to the 6th. We break that down. The square root of 81 times the square root of y squared times the square root of z to the 6th. Okay? Okay. Let's work it down further. The square root of 81. Well, we know that's 9 times 9, right? Times the square root of y squared, which is y times y, times the square root of z to the 6th. So what two things added, multiplied together where their exponents are added, give you 6? It would be z to the 3rd times z to the 3rd, because then that would be z to the 3 plus 3, z to the 6th. All right. Coming down here then, s is equal to, well, the square root of 81, positive 81 then is positive 9. And the square root of y squared is y. Well, let's look at this. From our previous example in the beginning, when we said x with the square root of x squared was x and x, we don't know if x is positive or negative, okay? So we have to put absolute value signs around that x to force it to be positive. Okay, so this would be the absolute value of y. But what about this term right here? The z to the z cubed times z cubed. Z cubed can in fact be negative. Okay, and I think we've gone over this once before, but let's say if you just had an example, negative 1 cubed, okay? Negative 1 cubed, the exponent is how many times you multiply together the base, and negative 1 is the base. So you have negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 gives you a positive 1. And then this guy comes along, and you multiply by a negative 1 again, it gives you a negative 1. So negative 1 cubed is equal to negative 1. All right? So here's the rule. When you have a factor under the radical sign that is even, okay, for radical expressions where the exponent of the variable under the radical, in other words, the 6 here and the 2, is even, 2 and 6 are even, and the resulting simplified exponent, in other words, the y times y and the z cubed, that exponent is odd, you have to use absolute value signs. Okay? So, let me write this down in words. So we look back here, and how does that apply here? All right? Well, the y's, this resulting simplifies to y to the first power. Okay? And the square root of z cubed times z cubed is z cubed, and that's an odd power. Okay, so that means that the absolute value signs have to be around those two terms. All right, so in the end, our answer is s is equal to 9 absolute value sign y z cubed absolute value sign. Okay. This guy is fairly important that you understand him so that you don't mess up the answers in the homework, okay? Because you're going to find radical signs cropping up left and right, and if you don't understand what we just wrote down, you're not going to have a clue as to why they're showing up, how, where, all that stuff. So make sure you understand this before you move on. Okay, that's it. Thank you for watching this video, and this is a involved section, so if you have questions, email me and I will try to answer them. Okay? All right, I'll see you guys next time. Bye.